Hello and thank you for viewing my video. Today we are going to take a look at EtherChannel, also known as port aggregation. Topics covered in this video: Cisco's discovery protocol, EtherChannel and port aggregation, the channel group command, link aggregation control protocol LASP, and we'll demonstrate how EtherChannel helps us with redundancy. For ease of demonstration, we will be using Cisco's packet tracer program available for free at cisco.com. EtherChannel is where we take two or more physical links and logically join them together to represent one logical path in the network. Besides providing link redundancy, it also allows us to utilize the aggregate bandwidth of the physical links. That's why it's also called port aggregation. For example, if we use two 100 megabit links in an EtherChannel, we would have the aggregate link bandwidth of 200 megabits. We are going to take this network topology from the Spanning Tree 3.1 video, and we are going to add EtherChannels between all of the switches. I have gone ahead and added the additional physical link to the network for each link between the switches. Now we will go ahead and configure EtherChannel. We will start with switch 1. We can see all the connected ports are set up as trunks. All the ports we add to the EtherChannel need to have the same speed, duplex, and if they are trunks they need to be configured the same in order for EtherChannel to work properly. To help identifying the links that are connected to each switch, I'm going to enable CDP, Cisco Discovery Protocol, with the CDP run command. CDP is a layer 2 Cisco proprietary protocol that, when configured on both sides of a link, will give you information about the attached device. The standard non-Cisco version of this is LLDP, or Link Layer Discovery Protocol. With EtherChannel, you can configure up to 16 Ethernet ports of the same type. Up to 8 ports can be actively carrying traffic, the remaining ports would run in standby in case one of the active ports goes down. For this exercise, we will use 2 ports in our EtherChannels. I'm shut down the interfaces as I configure the EtherChannel. Next, I'll issue the channel group 1. 1 is the number being assigned to the EtherChannel. Mode refers to the type of EtherChannel negotiation we want to use. The negotiation protocol choices are PAGP, or Port Aggregation Protocol, which is Cisco proprietary, or LACP, or Link Aggregation Control Protocol, which is a standard protocol. There is also AON option that bypasses negotiation. Each of the negotiation protocols have configuration options for bringing the links up. We are using LACP today, and we are going to configure both sides to active. Active will bring the link up, as well as active-passive, but 2 passive links will not allow the EtherChannel to form. And that is all there is to create the EtherChannel and add the physical interfaces to it. Each switch will have 2 EtherChannels, so I will create the second one. Next, we are going to configure the EtherChannel as trunk because we want them to carry multiple VLANs. We configure them just like the physical ports. First the interface name, then switch port mode trunk. When I run the show interface status on switch, the EtherChannels are displayed as PO1 and PO2. We can also see the PO1 and 2 are trunk interfaces. Now I need to configure the other 2 switches for EtherChannel. CDP run first to easily identify the ports. Now the interfaces for the first EtherChannel. And now the second set of interfaces. Next, configure the newly created port channels as trunks. I'll verify they were indeed created. Now the last switch. Now let's enable all of the physical interfaces we shut down on each switch and see if the port channels come up. Looks like they came up. Let's see if this changed anything with our spanning tree configuration. Here we can see the port channels are being displayed where the physical fast Ethernet interfaces were displayed before. Let's take a closer look at the port channels we made. Let's run the command show interface port channel 1. Here we see the physical ports that are members of this port channel. Here we see the port channel speed and duplex, but this is an error. It should read 200 megabits and full duplex because our F interfaces are 100 megabits each and both are set to full duplex. So I did a little research and found that this is actually a bug with this version of Cisco's packet tracer. I emailed Cisco's support but have not heard back as of yet. Next I'll run the show EtherChannel summary command. This command shows both port channels, the negotiation protocol it is using, and the physical ports. We can also see the flag indicators. S for layer 2, U for in use, P for in port channel, and finally the show EtherChannel, port channel, command. This will show all of the port channels on the switch. The port channel number we assigned, the LACP protocol, and the physical interfaces we assigned it. Scroll down and we see the information for the other port channel that was created. Now let's do some redundancy testing. I am going to ping the gateway for this PC, which is the router. You can see ping is working to the router. Let's shut down one of the links and see what happens. Let's run through the commands to review the port channel on the switch to see what they look like now that the physical interface is down. Show interface port channel 1. Here we can see the interface we shut down is no longer showing as a member of this port channel. Show EtherChannel summary. We still see both physical interfaces, but now FA02 is showing D for down. Next, show EtherChannel port channel. And we can see ports in port channel 1 are only showing FA01, where port channel 2 is still showing both of its ports. Now the interface is down, let's ping the gateway again from the PC. I can still ping the gateway. Let's turn down another physical interface in the topology. Even with 2 links down, we are still able to ping the router. And to drive the point home, we will shut down a 3rd link. And even with 3 links down, our PC can still reach the router. So now you can see how helpful EtherChannel can be in building a highly available network. Let's recap. We turned on Cisco's discovery protocol. We discussed EtherChannel and port aggregation. We configured port channels using the channel group command on the physical interfaces. For port channel negotiation type, we used LACP. Because the physical interfaces we used were trunks, we configured the port channels as trunk. We tested redundancy. And always document. Thanks again for watching this video. Please give a like and subscribe so you will be notified when more videos are uploaded.